When we're talking about SAOs, we are talking about small, simple things that either blink or eliminate the need for batteries or other things that are intimidating for beginners. So when we are making something for a circuit board, then we typically have a bunch of components we need to worry about. We have the PCB, which I showed off a little bit last time. And I think I showed off last time that this was my circuit board. It has a lot of cool art stuff on it. And I also took a little bit of a shortcut. There's another integrated circuit. There's another breakout board that is almost exactly the same as the one that I'm attempting to use for this, that is included in Kicad. And I was like, wow, that's so convenient. I can just do this. So this is my board from the artistic side of things. Now, in order to make this all like blinky and work, like naturally we need a footprint here. And I was lucky enough to find one in Kicad, but most of the time that's not going to be the case. You're not going to be able to find the perfect footprint for exactly what you need. So let me pull up the board we're going to use today. It's going to be an ESP32S3. So most of the time we're going to be working off of a data sheet or something. And in this case, let me pull. All right, here we go. This is what we want. This is what I'm going to be using. This cool, cute little board that is going to give me everything I need all built in. I just wanted the photo. Oh, right. Okay. So here it is. So like I said, I managed to find another board that has the exact same pin spacing. That's really useful. But if I wanted to use this for my SAO, then how would I actually add this if a footprint didn't exist in Kicad? Let's say that we want to use this. So how would we actually go about doing this? Well, most of the time it's got board specifications. It'll have a data sheet. Here it's just bragging about everything. And we can see like there's a lot of things that we could also additionally use if we really wanted to. Now you can see that there's all these extra pins on the bottom. That's really cool. But really we're just going to deal with these castellated pins. And castellated means that it's like basically it's like a through hole pin that goes all the way out to the side, has all this extra space for soldering, but it can also be done via through hole. Now, for the purposes of what I'm doing, I'm treating this as just like a soldering pad. So it's going to be flat. I'm not going to be doing through hole. I'm going to be doing SMD instead. So that's an important distinction because you kind of have to decide with these modules. And it's nice, though, to have the option. So these obviously have all sorts of cool stuff. They're going to enable that awesome demo that I showed off where I'm like visualizing invisible Wi-Fi like packets. But in order to do this, we need to place our footprint. And we have all this information. We've got the pin definitions. How wonderful. But what we really need is this, the outline dimensions. So if we want to make our own footprint, this is actually, I think this is more or less exactly what we need. So we might need to get the actual like pad size like a little bit correct, but for just making a rough footprint, associating it with the correct pins, it shouldn't actually be that difficult. So let me show exactly how to do this in case you want to use something like this and create like an SAO or something like that using a footprint. And again, I'm just kind of learning this, and I had a great guide I was going to share with all of you before everything got nuked. So here in Kicad, I can go to the footprint editor. There's a couple steps that I might forget, maybe, I guess we'll see. Yeah, so I'm going to right mouse click on a library and do a new footprint. And then I'm going to name it. And this is also where we can decide whether it's an SMD or through hole pad. Or design. So in this case, it really matters. And the difference between the two is a SMD or surface mount design is going to be something that is soldered flat. It is going to be much more manufacturable by machines. And you'll find that there are a lot of modules that are done this way in order to conserve space and make it so it's easy to mass produce these. A through hole design is different. It means that, you're putting pins through the holes and then you're soldering them all together. It's going to take a little bit more time and a little bit more space in most cases. And often manufacturers prefer SMD for just efficiency. They can set up a machine to do it. You can like solder paste and then use a machine to pick and place a whole bunch of these all at the same time. So in this case, we're going to do an SMD design, which is cool. I just again want to point out that this part that I'm using, this microcontroller, actually could do either. So it's really cool that if I wanted to, I could also do a through hole design for this if I'm feeling a little bit intimidated with the SMD. So kind of a hybrid one that I thought was pretty interesting. All right, so going to make a new footprint. And then here, I just want to show off like the basics of doing this. So here we can see that this is 18 by 23.5. So the way that this like whole thing works is by grid sizes and like by snapping to different things on that grid size. So in this case, we need to be able to snap to like a 0.5 grid size. So I think like this, let's try this out. So if I want to do, what was it? 18 by 23.5. Let me see if it lets me do it. So I'm going to go to a square. Oops. Come on, Kicad. Oh my God, please work. All right, maybe if I move this to my other screen, it'll let me select the tool. Okay, yes, it has now let me select the tool. Why that happened, I have no idea. So let's try it again. Whoa, we're lost in space. Where's our reference? There we go. Okay, sometimes these design tools freak me out. All right, so here we're gonna try to go to, oh, no, okay, so I've set it too high. So in my ignoring of the decimal, I have made it so that I'm instead snapping to 5 millimeters. So let's try 0.5. So I wanna do 18 by, I've already forgotten, 23.5. Yeah, so that's it. 18 by 23.5. So this should be the appropriate area. That looks more or less correct. So then if I hit M, I can move this over and kind of place it in the center of the reference area. And that should be good enough for now. And if you're OCD and are noticing that like it's not perfectly centered, then yeah, that's just me. That's just how I operate. All right, so we've got a basic area, and now from what I understand, I need to convert this into an area where I am basically telling the manufacturer to not put other stuff there. So I need to specify that I want to keep things out. And in this case, if I right mouse, let me see, I'm gonna switch to this tool. I'm gonna right mouse click on it, and I'm gonna say create from selection, and then create rule area from selection. And what I want to do is first uncheck delete source objects after conversion. I want to keep them. And then I'm going to get rid of keep out tracks, keep out vias, and instead keep out footprints. So basically keep out pads and keep out footprints is just telling the manufacturer that I don't want to put any other stuff in here. And I want to make sure that it stays, like clear for the part that's going to be like put down in this space. So I'm going to hit OK. And now there's like this hashed kind of output around it. And if I hit the option 3, then of course it opens the wrong window, but then I get this footprint here. So we're just getting started, but this is like the first requisite thing of what to do. So this is like the base thing. I've got the size, I've got everything else. Now I need to go to the reference and I need to take a look at the part dimension. So I can see here that all the different pads are 2.54 millimeters apart. So I need to be able to snap basically to that size and have all these different pads then be from center to center of the pad about that distance. So over here, I'm just going to do this in kind of a basic way and a very lazy way, but I'll show you how lazy people do this because maybe that's how you'll want to too. So here I can select the pad. There's also, I think I can select like different pads, but this happens to be the type of pad I'm already looking for. So that's fine. You can see it's just like a flat pad and I can modify these to be different if I want to. So I'm going to also put my pad basically all the way up against the edge. And again, I need to make sure that I can snap to the correct distance. So this is 2.5. This needs to be 2.54. If you kind of poke around in the grid, you'll notice that there's a lot of like kind of random ones. 2.54. Oh, wow, how convenient. The exact spacing that I need. Okay, great. It's almost as though it was standardized. So I'm going to place this, let's say, here. And then I'm going to do another one and another one. And before I go too far, I can then take this measuring tool and do like center to center and make sure that I have not messed this up somehow. 2.54 and quite largely as well. Okay, cool. So that looks correct. This is actually looking pretty good. So let me go back over here. So I'm going to keep placing pads. And if I go over to the reference, I can see we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9 pads. One, okay, yeah. Is that okay? So now what I can do also is I can space these appropriately by selecting them all and then changing, let's say that these need to be within 1.59 of the top. So I don't think that there is one of those. 1.59. No, I don't think so. We have like 0.508, but I'm just going to select that for now as a reference, and then I can move this around and see if I can space it a little bit more accurately for where it needs to be. So I think that this is pretty close, and honestly, provided it's consistent on both sides, like I think it should be fine since there's not a lot else going on my board. But I'm gonna, I will double check this before I do it. Now, I also want to point out, I probably want to move this over a little bit, and I don't want it too far over, but I do want it to be basically touching the side here. And if I look, I think that I could flood this with copper and make it so it really makes contact like on the inside here. But I would want it to probably just be a little bit on, if not the outside, just up to the edge here as well. So I'm not going to worry too much about it yet, but that's just something I would do if I wanted to make this design a little bit better. So, all right, so now I have the other side to do as well. And what I'm going to do is be lazy. So I'm just going to take this, select them again, copy, and paste them. And look at that. So now, provided I'm snapping to, let's make sure I'm snapping to the same 2.54. Okay, now that I'm still snapping to this, if I come over here, oh, I can get closer on this side. All right. Well, this is more what I'm looking for, is it basically kind of touching the side, and Kicad might not like that. We'll see if it doesn't like that, but that's kind of the idea here. So let me try moving it in just so it's symmetrical. All right, so that's where we are for now. And you'll notice now that the numbers are wrong. So how do we fix that? Well, I can go in and oops, I don't want all that. We can go in and we can adjust every single one, or we can just select all of them and then change them automatically. Sorry, I'm just going to move these to the outside. It's bothering me because I do want to make sure that the solder is going to flow all the way and use as much as the pad as possible. No, not just one. Wait, yes, to that one. So I'm going to right mouse click and I'm going to say that I want to renumber pins. So we're already at 9, and let's say that I want to start at 10, and then I want to do a step of 1. So that means each pin increases by 1. So this would be useful if I wanted to do a step of 2. If one side was even, one side was odd, that would be useful. So let's go ahead and do this. So we're going to start with 10, 11, 12, 13, 14, 15, 16, 17, 18, and there we go. All right, so we've renumbered our pins. This is not, by the way, how these pins actually are. The next step would be for me to go through and actually make sure that it matches this example here, and it would be 1, 2, 3, 4, 5, 6, and then RX, TX, other random ones. So then if I wanted, let's say that if I did want to name this correctly, and this is 5 volts. Now 5 volts. So we've got a 5-volt pin now, and then we got that. And then if we want to also make sure that the person who's putting this together is able to reference it properly, we can select the text tool. And then let's say we do 5 volts, and we can then place that right next to this. And also, if we wanted to rotate it, we could do that here. So let's say I want it 5 volts this way. I don't know why I would want that, but let's just say that that's the way I do. Place it. And then when I do option E, oh my gosh, don't you rebel on me, computer. I'm so skittish about Kicad and this demo in general today after everything that's happened. There we go. Okay. Whew, that was horrifying. So, all right, what do we see here? We see that we've got a silk screen layer that is going to show us what the number of the pad is, or other information we need to assemble it, or at least orient it correctly so we don't flip it upside down and put it on backwards. We've got these shiny pads, there we go, shiny pads, which are ready for soldering. So that means we'll be able to place our component down on top of this. And again, for the type that I'm doing, I might even place this just outside the footprint if I want to make sure the pads are really, really big and easy to solder. What's important here is making sure that the dimensions are accurate according to the footprint, again, which is referenced here. So provided we have a data sheet that shows us all these dimensions, what the distance should be between all these parts, and provided that they all look consistent for what we're expecting, then we should be able to work with this in order to create a footprint. And then once we save this, we should be able to add it to our PCB and connect a component that otherwise might not be supported in Kicad. So obviously, I've still got some work to do on this, but that's the basics. I would just go on and continue to label the pins accurately and then save this, and I would be able to then import this and use it in my Kicad project.